My name is Nahum Das, and today I'm doing a presentation in Math 147. I will be talking about the Gateway Arch that is located in St. Louis, Missouri. The Gateway to the west has over 4 million visitors annually. It has an observation deck that is centered at the peak of the arch that is 65 feet long and 7 feet wide. It requires a tram system to get to. The arch itself is 630 feet tall by 630 feet wide at the base. I want to describe the shape of the arch using a mathematical function that is able to be used to analyze other situations. To describe the shape of the arch, I will start with using this parent function, which is y equals x squared. That gives us the shape of this graph here. The function has not been tampered with yet. I'll show you how I got to turn this parent function into one that will approximate the size and shape of the Gateway Arch. Since I know the arch is 630 feet tall and 630 feet wide, I could determine what its graphing form looks like. By making this illustration here, I can determine that this looks close like my Gateway Arch. It is 630 feet wide and also 630 feet tall. I also have my x-intercepts from this point and this point. My vertex is 0, 630. 0 is my h and my 630 is my k. My x-intercepts are negative 315, 0 and 315, 0, which are labeled x, y. I can plug them in to this form right here, and then once I do that, I need to solve for a. So now I'll plug my x for my x-intercept and for x, and then I'll plug my 0 in from my h at the vertex, and also I'll plug my 630 in from here at the k. Also plug in your y, that belongs there. 315 squared, and that came out to 99,225. I subtracted 630, brought it over, getting rid of this, and then also dividing it over here. My a will be equal to negative 2 over 315. So now I got f of x equals negative 2 over 315, parentheses x squared plus 630. Now you can see how I got from this graph to this graph. This function is what this would look like. I want to know how high a visitor would be if they were to go to the observation deck and stand next to the end of the wall. So we could see that we are at a center line right here that's splitting the observation deck in half. It's got a total length of 65 feet. Since it's on the center line, half of it is 32.5 feet. I'll plug in 32.5 feet in for my function, and this will get me y equals 623.29 feet tall. Now what if I had a visitor that was 600 feet above ground? I want to know if they will be inside the observation deck or not. So what I would do is set my equation equal to 600 and solve for x. So I've set my equation equal to 600, and I've subtracted my 630. I get negative 30. I'll get rid of it, and then I'll do the same thing over here. 4,725 is equal to x squared. Now I'll do the square root property. Now I get two solutions, which is plus or minus 68.74 equals x. Since I got two solutions here, this means that I have two locations. The visitor at a height 600 feet above ground is outside the observatory deck because from before I found out that since the deck's farthest end wall was at a height of 623.29 feet above ground, this makes it impossible for the visitor to reach the room at 600 feet. I think that this assignment challenged me in a couple of different ways, where I had to learn how mathematical concepts can be applied to real-world applications. It made sure that I understood symmetry and transformations, and also parent functions and how they can be used. I guess going through this class has helped me really think critically about this problem.